Hello everybody. In this video we will discuss another problem for our elimination reaction of alcohol, and I'll give you some shortcut tips here. So let's start with this particular problem. So how would you solve this one? Well, let's look at our mechanism. So sulfuric acid is going to give you H3O plus. So one of the proton will get abstracted by the oxygen from alcohol. What kind of alcohol is this one, by the way? This one is your tertiary alcohols, right? And we will make this OH2 plus. And what is the next goal? Every time you have a positive charge on oxygens, your goal should be neutralize it, to neutralize it. So let's do that. So when you neutralize it, all right, so you can neutralize it by removing the CO bond here. So the water will take away both of the electrons. So now you will have a positive charge on this carbon atoms right there. So you have a positive charge right there. So this one is your tertiary carbocations, right? Tertiary carbocation is very stable. So we don't have to worry about any rearrangements or anything. Okay, so now what shall happen? So you have water that would abstract a hydrogen from one of the neighbor carbon atoms, right? So now you have a couple of choices. You could abstract hydrogen from here. So that's option A. Or you could abstract hydrogen from one of these red hydrogens. Okay, so let's say we abstract one of the hydrogen from here. So you abstract this and bring back the 2 electron here. So what is your product? So this is option A. We'll see which one will happen. Okay, so option A is the green hydrogens. So you will end up making this. Okay, so let's draw slightly better. However, if you abstract the water, if the water abstract the hydrogen from one of the other 2 hydrogen and bring those 2 back there, option B, you will end up getting this one. So you will end up getting this one. So if you notice, this alkene here is a lot more stable. The alkene here is a lot more stable because it is triply substituted. So you are 1, 2, 3. But the alkene here is less stable because it's doubly substituted. So more substitution means more stable. So this alkene here is more stable. Why? Because it is more substituted. Substituted. Okay, there we go. It's more substitutors. Okay, so this one is gonna be your major product. This one is gonna be your answers. So not this one. So always look for the alkene that is more substituted. So that is a shortcuts. So this is called Z-Sips rule. So Z-Sips rule tells us when you have when you have multiple choices of removing hydrogens, so hydrogen will be eliminated. Hydrogen will be eliminated from the carbon atom that has already the lesser number of hydrogen. So let's look at this problem. Or in other way, you will make more substituted alkene. You will make more substituted alkene. Okay, so let's apply this principle for this particular problem, and we will try to do this in a shortcut way, just applying directly, how would you do this problem? So let's look at the carbon atom, the alpha carbon atom that is connected to oxygens. It has three neighbors. Okay, so let's number them. And let's look at how many hydrogen each one of them has. Well, this one has three hydrogens. This one has two hydrogens. And this one has okay, I wanted to draw a different problem here. Sorry, I want to draw another carbon atom here. So this one has one hydrogen. So hydrogen must be removed from this particular carbon atom. So this is the hydrogen that must be lost. So when you are drawing the product, so you should remove, so when you're drawing the product, you should remove this hydrogens along with the OH. So that's the minus water right there. So that's your minus water, and bring this 2 electron there. And that's gonna be your answers. So this is your major product. Okay. The other choices would have been, other choices, those are gonna be minor product. So what are the other choices? You could have end up making like this, or this is probably the least favorable one. You could have end up making this as well. So this one is triply substituted. This one is only doubly substituted. So probably this one would be the most stable. This is second. This is probably the least stable. Okay, so that's how you're gonna do this. All right, let's stop here.